Donkeys are mean?
Well,
I thought that was mules.
Mules are a little more tame. Trust me, when the donkey.
All right, come on, guys. Find your seats. Let's go.
People really suck at putting a fence up. I want to watch these guys.
No, take your seats. We're going to be out of time. We got to go. All right. Here we go. Hey, I asked you guys 3 times, take your seats. Caleb was the one that was being nice and not saying, get out of my way.
I was just watching.
Now he's going to be truthful. All right. So we had the worksheet last night. Any challenges with the worksheet since you already had the answers? Easy or hard? Chandler. All right, good. And that's a good thing. I'm just going to say, and I just talked to Bailey, I'm like, if you walk into the class like right now and you hear us talking and you haven't been for the previous classes, it's going to seem like we're doing, you know, I don't know, black magic or something like that because it's weird, right? We're going to run through the stuff today and you're going to do well on it. Why? Because we spent 2 days practicing on the stuff. And we do have a quiz on Monday. The quiz will be on what you have in front of you, that worksheet. If I made a quiz out of those questions, would you be confident you'd get an A?
Yes.
Okay. I'm not collecting it. I'm going to give you credit for it, even if you didn't do it. But I'm going to warn you, the quiz is going to be on that worksheet right there. All I'm going to do is cut it down to about, I don't know, 10 questions. It's going to be exactly the same as the worksheet. I'm just going to
see it something.
I'm just going to make about 10 questions out of it. Okay? We good? All right. I'm doing geometry in the other one. Oh. All right. Hey, today is, I always slightly lie. Today is a challenging class. Today and tonight or over the weekend for homework is nothing but proofs. There's not a single question that isn't a proof.
Let's get this. Oh, this one. Is it the 1 through 5 that I already did?
You gave me 3 or 4.
Pass behind you. All right. There's only 5 problems, but they're all proofs.
I already did this in front of That was my homework the other day that I turned in.
Yeah, it was wrong.
I don't know. It was. The proof was wrong. No.
All right. Now you're going to do it correctly. Okay. You didn't get one?
Watch me. I'm going to show you.
I thought I gave you 2 to hand behind you.
I never feel mine. Here you go,
All right, here we go. Now, we are only going to do, quiet please, we're only going to do about 5 proofs in class. And you're like, wait a minute, only? That sounds like a lot. We're only going to do 5. We're going to do 2 main things. You got to stop me if you don't understand the concept. You might, I'm going to claim that you probably will get these proofs. They're not that bad. But if you don't understand the concept, stop me, with the exception of Bailey. Right? But all of the rest of you, stop me if you don't get this concept. All right. This is a tough class for some. For others, it'll be what? I didn't think it was tough at all. I thought it was pretty easy. You're going to fall somewhere in that continuum between really tough and it was pretty simple. The big picture of what we're doing this class is 2 things. I'm going to show you this really quickly. It's going to cause your head to spin a little bit. Don't panic yet. I'll tell you when you can panic. So you're going to be asked 2 basic questions tonight and during this class. 2 basic questions. I'm going to ask you, this is the easy part, are 2 segments congruent? Okay, I can wrap my head around that. And the second question is, are 2 angles congruent? I can wrap my head around that as well too. That's the big picture. So the big picture is kind of easy to understand. The doing it is the more what you got to have, what the class is really about. So now that brain is like really turned on, you're watching, you're paying attention. Here we go. So here's what you will do. I don't have anyone write this down because it takes too long to write it down. And I wait to the end of class to ask, does anyone need to write this down? But don't panic if I show you this part and you're like, well, I don't get any of that. Okay, here's what you're going to do. You're going to show that those two parts, see the two sides or two angles, are part of two different triangles. Then you're going to prove that they're congruent by either SSS, SAS, or ASA. Monday we'll get AAS. We don't have it yet. Okay. And then lastly, you're going to claim CT, CTC, and you're done. If you can't wrap your head around that, don't panic. I'll ask this question at the end of class. Okay. So some of you are like, what's going on? Right? Don't panic. Okay. So we'll start off really simple. And by the way, these are nothing but proofs today. You're going to prove that angle A is congruent to angle C. You see the two angles? Okay. So let's see. What did I say? The first thing you're going to do is you're going to show that the parts that you're trying to prove are part of two triangles. That's not a triangle. That's not even one triangle, let alone two triangles. So if step number one is to show that the parts A and C are part of triangles, what do? Whoops. There you go. Hey, now we got two triangles. Okay, that's not true. Now, we had an option of drawing that diagonal. We could have drawn it from A to C. Why didn't we draw it from A to C? Then I would be cutting the angles I'm trying to prove it, maybe in half, maybe not in half, but now I doubled my problem. All right, now I got to show the two parts of, it would be much more complicated that way. So tonight for homework on a couple of the proofs, you might have to draw, this is called an auxiliary line, okay? And you can do that on a proof. We okay with the basic idea? So step number one to prove that two angles are congruent, show that they're part of two different triangles. That's not too bad, right? Hey, they're part of two different triangles. Step number two, prove that the two triangles are congruent. What three ways do we have to prove, Amaya, that the two triangles are congruent? SAS, pretty good. Okay, so those are our three options. Monday we'll get AAS. All right, okay. Well, in order to do that, we got to start throwing some congruency symbols up here. So this one's a bit easy. Hey, this side is 4. It's on the top triangle, if you want to call it the top. Well, there's another side that's 4 on the other one. So those two sides must be congruent. You okay with that? Yes? Hey, this side of this triangle is 9, and this side of the other triangle, therefore they must be congruent. You okay? All right. Wes already wants to answer this. Anyone else?
No, I don't.
Chandler wants to answer it. Bailey, you want to answer it? Okay, because she doesn't know what we're doing. You guys, as you're looking at it, should immediately be thinking, Jenna, do you see anything else up there? This is that trick. Do the two triangles share anything in common?
The two sides.
Okay, anything else besides the two sides?
Oh, the line in the middle.
Oh, the line in the middle, we call that the, starts with the letter R. Amaya, help her out. Starts with the letter R. You did this yesterday. Yes, you do, because you did it yesterday. Go ahead, Wes. The reflexive property. Remember, reflexive, you're looking in the mirror, your reflection. You are the same as what you see in the mirror. The reflexive property just simply says that two things that are the same are equal to each other. Duh. Now, this cup of coffee is equal to this cup of coffee, right? Notice on our picture, we got a triangle on the top and a triangle on the bottom. They share this diagonal line. That's a side of both triangles. Therefore, it's congruent to itself. Reflexive property. By Monday, we shouldn't be having this pause. I mean, Wes' hand immediately, before I even asked the question, his hand was in the air. You know, Cadence, as soon as I started to ask the question, she was like, oh, I know what the answer is. You guys got, and Chandler as well, too. You guys got to be on the ball with the reflexive property. Okay, Amaya, how do we show that two triangles are congruent? What are our options? Or SAS. Look at our two triangles. What are we saying here? Boom. We just proved that the two triangles are congruent by SSS. How do you get, where's the angle? No. That's what we're trying to prove.
Oh.
We don't know if they're congruent. It turns out they are, but we don't know that yet. Okay. We just showed that both triangles are congruent. If we were doing a proof, now we could write a congruency statement, yes? And just be careful with your congruency statements. It doesn't matter which letter you start with. I start with A. If I go to B, I'm going across the one with 2 tick marks. You see that? So I go 2 tick marks, 3 tick marks, 1 tick mark. So if I go down the bottom, I would have to go 2, 3, 1. Well, that would mean I would have to start with C. You see how I'm getting that? 2, 3, 1. You got to have the same pattern to write your congruency statement. The last step to show that A is congruent to C is literally the easiest step. You just showed that triangle 1 is congruent to triangle 2. Then therefore, by this magic thing called CPCTC, which stands for, say it, corresponding. We just showed that 2 triangles are congruent. So that means their corresponding parts are congruent. How do we find corresponding parts? Triangle congruency statement. A goes with, you're done. That's it. That's the whole proof, by the way. Yeah.
So how would you write the beginning steps out?
We're going to do a true proof here in a second, but I didn't want to get too complicated. All right, we're going to do 3 of these. First one, you might be, okay, I kind of see what's going on. By the third one, you need to be asking me questions if you don't understand. All right, these were the 3 steps to show that 2 parts of one triangle are congruent to 2. Sorry, these are the steps to show that 2 parts of 2 different triangles are congruent. Show that they're part of 2 different triangles. Show that the 2 triangles are congruent. Claim CPCTC, and you are done. Danny, were you paying attention? Okay. Let's do another one. Danny, you're up first. This is box 2. Now let's write. Danny, can you read the given statement? What's PR? What's PR? What is that symbol? So you say line PR. Keep reading. What's this thing? And what is this thing? It's not a line. Segment. Perfect reading now. Okay. We good on the given? So if we were writing a proof, our first thing would say, given, right? We're trying to show that this angle Q is the same as S. Are they part of 2 different triangles? So we don't have to do that thing of, drawing a diagonal. They're part of 2 different triangles. Now I need to prove that the 2 triangles are congruent. So Danny, we start with the given. What does bisect mean? Through the middle of it, meaning it makes 2 different or same parts? 2 same parts. So if it goes through QPS, the first thing I do is find QPS. Hey, QPS. See what I did there with my pencil or whatever? I'm drawing it out. So what did it just cut in half, Danny? Did this red thing ever touch R? So what did it cut in half? How about, I'll go with angle P. Agreed. It cut angle P in half. What are the 2 parts? Nope. I'm going to draw an angle, and I'm going to cut it in half. Where are the 2 parts? Could you touch the 2 parts with your finger? Yes or no? So what are you touching on this shape? You're touching an angle. Your finger's right here. What's the name of this angle on that shape? Angle Q is the whole darn thing. What's this angle? Angle what? P is the whole thing. I got to give a name for this angle right there. What's its name? If you say it's P, well then what's this angle? They can't both be the same. They're 2 different things. Okay? We name angles 4 different ways. One way is with 3 letters. Danny? Q, P, R. That's the same as, for the other angle, we got to start, the middle letter has to be the vertex of the angle. SPR. So we could say that those 2 angles are congruent, yes? He's getting that from this statement right here, bisects. So let's do that on your proof, right? You can just draw a line straight down. I'll skip the given because it's boring, right? We'll do the only formal proof we're going to do is, I think, box 3 or 4. Why can we make this statement right here? Bailey, right. Why can we make this statement? What would be the conclusion? Justification for it? Definition of bisectors, right? Or angle bisectors to be more precise. Boy, I'm really writing some abbreviations there, right? Once we get to chapter 4, you can start doing stuff like this because we all know what it means. You can't do this in chapter 2 because nobody knows what it means. Okay. Are we done with the first part of the given? Can you get anything else from that?
Pursue teachers, this is just your reminder to take attendance, please.
One time that I forget to take attendance. Harris is the only one, right? Done. All right. Back to my love and joy, geometry. All right, let me catch up. Anytime. Okay, second part of the given. What do we got from the second part of the given, somebody? Hey, this is congruent to that. Well, I could put tick marks, right? So we just showed that this part is congruent to that part, 2 arcs. Well, the given says that PQ is congruent to PS, so I can put tick mark, tick mark. I mean, that's the given. We good? What am I picking on? Jenna?
No.
Amaya was like, wouldn't you show me your face? What else we got up there? Look at the picture.
I'm looking at the picture.
So say it. Say, well, what am I going to say, though, in the proof?
Oh.
Don't listen to Chandler, even though he's right.
Not TR intersect.
Not intersects. You're looking in the mirror. You're going to say, I is the same as what's in the mirror. So what are you going to say, though, in the proof? Yeah, but that's this thing. What you're going to say over here. You're making this way more complicated than it needs to be. Is, what does reflexive mean? You're way overthinking. You look in the mirror. What do you see?
Yourself.
So yourself is congruent to yourself. That's it. Now, what am I going to say for this one? It's that same idea. Yourself is congruent to yourself, except picture now. Just say that.
You're confusing me.
Are you confused on the statement yourself is congruent to yourself?
No.
Then just apply that to the picture. What is congruent to itself? Reflexive property. Is anyone else confused on the reflexive property? All you say is that part is the same as that part. It's like looking in the mirror. You are congruent to yourself. We have to say that because that's how we get to SAS, ASA, or SSS. So yourself is congruent to yourself. I forget if I put tick marks. I did. All right, Connor. It's hard. There's a mess there. Can you see why the 2 triangles are congruent? Why? This was the homework last night, by the way. What are our 3 options?
SAS, ASA.
Which one is it? Yes? Okay. So those 2 triangles are congruent. This is how the proof should be written, by the way. You have to make a congruency statement, which can be hard, but once the tick marks are there, just follow. Hey, I went QPR. I can go in any 3 letters I want for the top one, but the bottom one has to follow the same pattern. If I go QPR, I'm going 1 tick mark, 2 tick marks, no tick mark. So it's got to go 1 tick mark, 2 tick marks, no tick mark. SPR. Finish it up, Wes. So I just showed that the two triangles are congruent. Yeah, but what's the statement? What? What was I trying to prove here? What? Look at the proof. What was I trying to prove? Where are you getting that from? I know you were. So Q is congruent to S, Y, and you're done. That was number 2. You kind of getting the feel for this now? Is this hard? This one's pretty easy, right? And it kind of follows the same flavor, yeah.
In the book, they just put CBCT.
Yeah, there should be a second. I don't know why they leave off that second C or third C. All right, so once again, the steps are, you show that the two parts are part of different triangles, you show that the two triangles are congruent, and then you just simply claim CP, CTC. All right, last one, and we'll move on to something new. All right, I would expect us to be running this time, running. All right, Caleb, from the given, what can you say? You can tell me anything, any statement, but that's true because of the given.
Segment GR bisects. Angle.
Yeah, but that literally is what the given says. But you got to tell me what I could do to the two triangles because of the given. And by the way, he's right. That would be your first line of the proof, the given. But because of the given, what could I do to the triangles? I'm going to go back to exactly the same thing I did with Danny. What does it mean to bisect?
Cut it.
Cut it in half, not just cut it. You're cutting in half. What did I just cut in half? Okay, so therefore, what can I say if I cut it in half? Bless you. You got two things that are cut in half. You now have two things that are what? Different or the same? So what is the same now? You got to name it. PR is a segment. Could
KPS is congruent to K.
You're saying K? You mean Q?
Q. Yeah.
Okay. So say it again.
QPS is congruent to K. QRS.
No, that's not what it says. Okay. Can everybody see PR? It says that PR cuts this angle in half. So what two parts do I get from that? Finish it up, Caleb. What two parts are equal if I cut it in half? I'm confused at why we're confused here. Angle, yes, right here. If I cut it in half, this angle and this angle are exactly the same. That's the picture right there. Is that something you're not getting or what?
I get it.
Now tell me the names of the two angles that are the same.
Not are the same.
Tell me the names of them though.
QRS.
Okay, I'm not sure why you're going onto this side. Imagine that's not even there. Tell me, oh, that's there, right? Tell me what two angles are now equal to each other.
KP.
Say it again.
KPS.
You just said that angle. You said QPS.
Q.
That's the angle. That's the one we just cut in half. It's cut in half. If I were to draw the two separate, it would look like that. These two parts now are equal to each other. But you got to tell me the name of this one.
QPR.
Is the same as?
RPS.
Yes? Okay. Oh, by the way, it also says that it also bisects.
QRS.
So here's QRS, and we're told that it's bisected. So what two angles are congruent to each other?
QPR.
Q what?
QPR.
Why are you going over here? You see the picture now? That means that this angle is the same as that angle. What's the name of those two angles?
QRP and RSP.
Okay. And what? The first one was good. QRP is the same as?
RPS.
Yeah, you started with R. You can't start at the middle. So what's the second one? You gave me this one. There's QRP. Now give me this one.
SPR.
Okay, if you go SPR, you gave me this angle. I want that angle.
PRS.
PRS. Okay. Thank you for struggling through that, Dan. Or Caleb. All right. We good? So I can immediately say on my proof that this angle is congruent to this angle and this angle is congruent to that angle. That's a lot of messy writing. Oh, that's a horrible art, but you get the idea.
You know which one's the vertex, because like a QPR is good. Like, and then you got QRP.
Say that one more time.
You got QPR and you got Q.
So this angle QPR is the same as SPR. That's the first statement.
Yeah, but how do you go from QRP? How do you know that R is the vertex on the second statement?
Well, it says that PR bisects QRS. Where's QRS? It's right here. See it? Okay. All right. Amaya, what else do you see on the picture? Well, we've just used all the given. What else do you see on the picture? What else do you see on the picture that's true? Agreed. Do the triangles share anything? So what can we say about the side? To itself. Which side is that? Which side is congruent to itself? Which side is congruent to itself? Do you see that you have two triangles? Is this the picture or is this the picture? Well, this turns into this, but how does that happen? You smash the two together. So do they share a side? Which side? So what could we say? If they share a side, by the reflexive property, we could say PR is congruent to PR. There's our, why are you not clicking? Oh. Reflexive property. We've done that 3 times now. Are you getting the hint that we're going to be doing it a lot? You got to be looking for that. Okay. Next victim. Madison. Why are the two triangles congruent? Oh, I forgot to put. I just put 3 tick marks. I could have put 1 tick mark. Why are the two triangles congruent? Is that easy or hard? Okay. I'm getting the feeling that we're breaking up into 2 different types of groups here. The people that are wondering why it's taking us so long to get to the proof, and the people that are still clueless. Am I kind of right on that? All right? Okay. Oh, by the way, how do we end the proof, Madison? You just showed that this triangle is the same as this triangle. Yeah, but what do I write on this part? The proof part, right? And then the reason is CPCTC, okay? If you show that the two triangles are congruent, then that means all 3 parts sides, all 3 parts angles are congruent to each other. I don't mean literally all 3 sides are the same as the 3 sides, right? But I mean each corresponding part is congruent. That's what the P, or the C, the first C stands for. Corresponding parts of congruent triangles are congruent. All right, those are your 3 steps. We're only halfway there. All right, the second big idea is the same idea, except we're going to be showing that 2 lines are parallel. It's the same idea. To show that 2 segments are parallel, we're going to show that those segments are part of 2 different triangles, right? We're going to show that the triangles are congruent. We're going to show that the two parts are congruent by CP/CTC, and then we're going to say because these two angles are congruent, they're alternate interior angles. We're going to show that we have alternate interior angles. I got to show you one to show you what it looks like. All right. Once again, why is this so clippy? I don't know. All right, we're going to actually do a real proof this time. I mean, full-blown proof. I said we're only going to do one of them. Here we go. You see the two triangles, everybody? Okay. Step number one, write your given. Cadis, what does the given mean? What does it mean? Not that only that they cross, I get they do, they intersect, right? But what is the special thing about the words there? What does that mean? That cuts it in half. What gets cut in half? What? M is the midpoint, but what does it mean if it cuts in half? What does it mean if you cut something in half? If I cut this in half, do I make different or the same? So what can you say now? Because things are the same. Can't say the triangles are the same because I didn't cut the triangle in half. It says these two segments bisect each other. That means they cut each other in. So what could I say about the picture now? Can't say that. You said it cuts in half. How did I cut it in half? I don't have a pencil. I usually break a pencil in half. If I break something in half, where are the two parts? Name the two parts. Here's the first thing you just cut in half. Where are the two parts? Hey, here's the thing I just cut in half. Where are the two parts? Was anyone else lost on that? So where could I put tick marks? And so because of that, we could say this statement right here. The AM is the same as MB. We can't say that these are the same as the other parts, but we do know that it cuts the other parts in half. We just don't know if they could be the same. Doesn't look like it. But we can say that that part is the same as that part. Was anyone confused when they read that statement that this was the result of it? Because you're going to see that statement plenty of times. Bisect, it means you cut something in half, an angle or a segment. What's the reason? How do you know it cuts it in half? Don't overthink it. How do you know it cuts it in half? What? The definition of a bisector. That's what it means. You cut something in half. You bisecting, you're cutting the pie in half. Okay. Connor, do you see anything up there that we haven't said? We've used all the given, by the way. Do you see anything on the picture that stands out at you? Yes? No? Do you see any shape up there that you've seen before in geometry besides two triangles? Bailey, you've seen this before. Ignore an X. What's so special about an X? You nailed it. What's so special about an X? Whenever we make an X, guess what we always make? And by the way, she sees the X right here. What do we make when we make an X? We make vertical angles. And what do we know about vertical angles? They're congruent. So what's congruent here? What is it? AMD and BMC are congruent. Why? Because they're vertical angles. Oh, this proof is almost done. Vertical angles are congruent. Matt, why are the two triangles congruent? Why are the triangles congruent? Last night's homework, right? SAS. just be careful with your triangle congruency statement. So if I go AMD, I'm going 1 angle 2 tick marks. So I'm going to go 1 angle 2 tick marks. So AMD, if that's how I write it, has to go to BMC. Yes? Why? Matt said because of SAS. We're trying to prove that AD is parallel to BC. This is where it gets tricky. Pay attention. We're trying to prove that AD, see what I'm drawing? I'm drawing AD, is parallel to BC. They look parallel. What do we know about parallel lines cut by transversal? That what? Lots of things.
Their corresponding angle.
Corresponding angles congruent. I would have to extend that to make a corresponding angle. But I also know that alternate interior angles are congruent. We just showed that this triangle is congruent to this one. So I can say something about this angle and this angle. What can I say? If the two triangles are congruent, then what do you know about A and B? They're congruent. Why do I want to make that statement? Because I'm trying to make this statement. Okay? So I'm going to say that D, and you can pick either one. It doesn't matter which pair you pick. I just chose D and C. So instead of this one, I chose that one. So where are the alternate interior? This one and this one. B and C. Can you see that? You're going to have to do this tonight for homework. For the parallel line ones. And I could have chose A and B as well too. That would have worked. Why are they congruent? Because of CP, CTC. Stop, we're not done. 2 minutes. Okay, to claim that they're parallel, and they are parallel, this goes way back to the previous chapter, right? And the previous chapter said that if you have two lines cut by transversal and alternate interior angles are congruent, then you can claim that the two lines are parallel. I forget what theorem that is. It's a theorem, okay? In your book of truth, if you want to flip through it, you can tell me it's theorem, I don't know, 3 something, right? But if you can't remember the theorem number, then you gotta write it. Sit. Stop packing up. Sit. Okay. You find it, Cadence? No. It's probably not worth flipping back through because it's, you're gonna have to find it. You're not gonna remember it. We're gonna use this the rest of the year. Maybe that makes a case for remembering. I don't know. But I never remember what number it is. All right, we only did one of these. Is tonight homework going to be hard or easy? Well, the parallel lines, because we only did one of them, might be a little bit more challenging. Hey, go on Microsoft Teams when you're trying to do your homework, replay this video. All of the ones that are parallel, if you can't figure it out, this is how it's done. It doesn't change. You show that two triangles are congruent. You claim that alternate interior angles are congruent because of CP, CTC. And then it's this statement and you're done. It works the same way each and every time. The ones where you're trying to show either pieces, parts, either angles or segments are congruent, we did 3 of those. How many times did we use reflexive property? Except for this one. This is the only one we didn't use reflexive property. You got to be on their toes. As soon as you see the shape, you should always, like Bailey, see the X or you see reflexive property immediately. Right? All right, have a good weekend. All right, e-learners, same with you. You guys might want to play this again as you're doing your homework. But one nice thing is that for all the homework problems, the way the proofs play out are exactly the way that I just did them for those both 2 cases. You're either showing that parts are congruent or you're showing that sides or lines are parallel. All right, I'll catch you guys next week.